Hello and welcome to Program 8. To start off, go to Blackboard and download the code file. And open it in your code editor. Now we won't need the main function for quite a while, so we'll just get it out of the way. Give ourselves some extra space in here, and we will declare our class. So to do that, we just type class, then the class name, which in this case will be quadratic, followed by an opening curly brace, and let's give ourselves some extra space. Now we want to declare our private data members, which we'll do by typing private followed by a colon. And here we just have three members to worry about, the a, b, and c values of our equation. And we'll declare those with just int a, comma b, comma c. Next we need our public members, which again we'll just declare with public. First off, we'll do our constructor, which will be quadratic, open close brace, and a semicolon. And then another constructor, quadratic, open brace, and this one will take three int values for our a, b, and c. Next up, we need a method to print out the equation, which we'll just call printEquation. So void printEquation, open close parenthesis. Next up, we need to calculate the x value of our vertex, which we'll do with double calc x. And then we need to do the same for our y value. So double calc y. Next, we'll need a method to print out the vertex, which we will do with void printVertex. Then a method to print the concavity, which we'll do with void printConcavity. And a method to print out everything at once, which we'll just call print. Now that we have all of our methods ready to go, I will take a moment and get them all below our main function so we can get ready to type them out. Now that we have all of the method headers below main, we don't need to worry about this first one, the default constructor, since we won't be using it. For the second constructor, we'll want to give our arguments some names. So we'll just give them the same names as the properties up above, just prepended with an underscore, just like that. And then on the inside, we just want to say b equals underscore b, c equals underscore c, and for a, if it equals 0 in the constructor call, we want a to equal 1. Otherwise, we just want it to equal whatever a was in the call. We'll do that with if underscore a equals 0. Then we'll do a equals 1, else a equals underscore a. For the printEquation function, we're going to do it in 3 different sections for now. We'll start off with the a section, so we'll do cout a followed by x squared plus. Then we'll do cout b x plus. And finally, we'll do cout c followed by a new line. For our calcx method, we're just going to calculate the value and return it all in one line. So to do that, we'll do return negative, and we'll need to cast our values as double for this. So double b divided by 2 times double A. There we go. So that will give us the x value of our vertex. For our y value, we'll just replicate the equation substituting every x with a calc_x call. So to do that, we'll just do return a times calc_x times calc_x plus b times calc_x plus c. For our print vertex function, we'll just be using these two functions up here to print them in the correct place. So we'll do that with cout, followed by vertex, and an open parenthesis. Then we will call that calc_x function first, followed by a comma and a space, and then our calc_y function, followed by a close parenthesis and a new line. For the print concavity function, we'll just be testing our A property to see if it's positive or negative. If it's positive, we'll print out the parabola opens upward. If negative, downward. We'll do that with cout. The parabola opens, followed by a space. And then if A is less than 0, we want to output downward. Otherwise, we want to output upward. Finally, for our print method, we'll just be calling all of our other print methods in sequence. So we will just run print equation, print vertex, and print concavity. If I've done everything correctly, we should be able to run it now and get some output. Alright, let's see. We got 1x squared plus 2x plus 1. 1, 0, that looks correct. 0, 25 looks correct, opens upward. Let's see, 0, 0, 833, 0, 0, 833, that all looks correct. Most of it's done now, so let's move on to some extra credit. We're going to start with extra credit 2, which involves finding the roots of the equation and printing them out. So first we need to add in some extra methods to our class definition, which are double calc discrim to calculate the discriminant, int calc roots, which will calculate the roots and give us the number of roots for the equation. And we'll need 2 double addresses as the argument. And finally, a method to actually print out the roots for us, which we'll use void print roots. Just like our calc_x and calc_y methods, we're going to calculate the value and return all in one line for our calc discrim method. So to do that, we will type return, and then the formula to calculate the discriminant is b squared, which will do b times b, minus 4 times a times c. We're going to skip the calc_roots method for now and go to the print_roots method. So first we'll want to declare some variables to hold our roots. both of them double, and we'll just call them root1 and root2. Then we need to create a variable that stores how many roots there are, and we'll just call it roots. And we'll set that equal to our calcRoots method, which we need to pass root1 and root2 into. Then we just need a couple of if statements based on how many roots there are. So if roots equals 0, we need to output that there are no roots. So there are no roots. Else, if roots equals 1, we need to output that there is 1 root at, and then we just need to output root 1. Finally, if there's more than 1 root, else cout there are 2 roots at root 1 and root 2. Going back to our calcRoots method, we will be testing our calcDescrim method to see if it returns a value greater than, less than, or equal to 0. So let's start off with the easy ones. So if calcDescrim is less than 0, there will be no roots, so we don't have to worry about calculating either of the roots. We will just return 0. Else, if the calcDescrim is equal to 0, then there is exactly 1 root, and that root is the vertex. So we will just return, nope, don't return yet. We want to set root 1 equal to calcx. And before we get too much further, we want to give these arguments some names. So we'll just stick with root 1 and root 2. Then back at equals 0, we want to return 1. Finally, whenever the discriminant is greater than 1, we need to actually use the quadratic formula to find the roots. So we'll do that with else, then we'll set root 1 equal to negative b cast to a double plus the square root of the discriminant divided by 2 times a cast to a double. And then we'll do the same for root 2. So root 2 equals negative double b minus the square root of calcDescrim 2 times a as a double again. And then finally, we want to return 2. One last thing, on the end of our print roots function, we'll want to output some extra lines so it'll be easier to read. So cout, and L, and L. Now we just need to add our method calls into our main function. which we just do with equation 1 dot print roots, equation 2, yada yada yada. So if we run this, it should work. Let's see what we get. There are 2 roots at 1 and -5, 1 root at 1, no roots, 2 roots, no roots, 2 roots. That all looks correct. Now we just need to add a print equation call to the beginning of our print roots method. So just add in print equation, and that is good to go. For extra credit 1, we need to alter our print equation method. So we'll start off by commenting everything out and starting fresh. So the way it needs to be edited, if any of the variables are equal to 0, we don't print that entire section of the equation. If a or b are equal to 1, then we just don't print the variable, and we just have the x squared or the x. So let's start with a. So if a equals, let's say, -1 first, we need to output a negative sign. So cout minus, else if a equals 1, we actually don't output anything, so I'm just going to put a semicolon there. Don't forget your parentheses. And then if a is equal to anything else, we just need to output a, like that. And then finally, cout x squared. For b, first we need to make sure it's not equal to 0. So if b does not equal 0, then we need to decide if we are printing out a plus or a minus. So if b is less than 0, cout a minus sign, else cout a plus sign. For c, we need to make the same check to make sure it's not equal to 0. So if c does not equal 0, then we need to do the same plus or minus check. If c is less than 0, cout a minus sign, else cout a plus sign. And we don't need to do this if it's equal to 1 check, since we will output it regardless of whether it's equal to 1 or not. So we'll just need cout absolute value of c. And to finish everything off, we will put a new line at the end. Now let's run it, make sure everything works correctly. Alright, we got x squared plus 4x minus 5. That looks good. X squared, negative x squared. No b on this one, no c on this one. Everything is looking good. So if you followed along this far, that is the end of program 8. Thank you for watching, and I will see you next time.